So today we are going to finish up chapter 2. Last section we have to cover is linear quadratic systems. This will lead us into, if you kind of look behind me, the week that is. We've got 2-7 today. Tomorrow will be a review of Friday and today. So those of you that were gone on Friday, the formula is right there underneath the football. We did the quadratic formula on Friday for those of you that were gone. If you need help on it, we'll talk tomorrow. Tomorrow will be mostly a day that you do your thing. So if you need help, I can help you with that tomorrow. Notice I've stretched the review into 2 days now. And then we're going to assess on Friday. This has been a long chapter, about 3 weeks on this chapter. And I'm a little bit worried when you start reviewing that you'll forget the first half of the chapter. It's been so long. So we'll give you a couple days for review and then the assessment. The review is multiple choice. The test is not. Okay. I don't know why I did that, but I did. So deal with it. All right. So today we've got linear quadratic systems. We've talked about systems of equations in the past. We've solved them whether they have 2 variables or 3 variables. But everything we've done up to this point have been linear. They've been lines. Now we're going to add the quadratic piece of it in there as well. And they're going to do it a couple different ways. The first way we're going to do it is we're going to just do it by graphing. But we're going to use technology to do it by graphing instead of just graphing them ourselves. When we talked about systems of equations, we said that graphing works, but it's not very accurate. It's even less accurate when you're talking about these. So therefore, we're going to use Desmos to do most of the graphing with the quadratics. So we're going to do that. We'll talk about solving them by substitution. And then we're going to look at we're going to look at quadratic and linear inequalities and solutions for those as well. So 3 things to do today. It's not that bad. A lot of Desmos stuff. We'll get through it. So linear quadratic systems. So we're looking at finding solutions to where we have one quadratic equation and we have one linear equation. Okay. So when we're talking about finding the solutions, we're trying to figure out where do they intersect. So we want to find the intersection point between these 2 things. Now, they're going to have solutions depending on what they look like and where they're at. If we look at these 2, and again, I'm going to look at it on Desmos, so just show you it on Desmos. If we look at this at Desmos, there's y is equal to x squared. The other one was it just 2x? I forgot what the other one was. Just y is equal to 2x. So y is equal to 2x is right there. So there are our 2 equations. And you'll notice that they intersect both here and here. Okay, so this case, there are 2 solutions to it. Our line intersects our quadratic or a parabola in 2 different spots. And we could find those spots. That's the point 0, 0. And that's the 0.24. Okay, so when we're talking about solutions, remember, the solution is not just going to be the x value. You're going to do a lot of solving for x. But once you solve for x, you need to make sure that you plug it in to get your y value. So these are the points that we're looking for. So you can have 2 solutions. If I take this and put -1, so I change that second equation, you'll notice now they meet at 1, 1. That's the only solution that they have. They don't meet in any other spot. Okay, so it can have 1 solution. Or, of course, if I change this to -2, there can be no solutions to these. They just simply never are going to intersect each other. This is going out at a much less of an angle than this quadratic is. So when you're asked the number of solutions, remember you're just looking at the points where they intersect. Okay? So now what I want you to do is I want you to go ahead and get your computers out, open it up to Desmos, and I want you to use Desmos to find out how many solutions are to those two. So we have y is equal to 3x squared, and y is equal to 3x minus 2. Remember, when you're using Desmos, once you open it up, use their keypad, don't use yours. You can get their keypad, it's on the lower left-hand side. It's much easier to use their keypad than to use yours. So again, just want you to, number of solutions that they have. And when you get your assignment today, when it asks you for the number of solutions, you're just going to use Desmos to do the first few. If you have a graphing calculator and want to use your graphing calculator instead, of course you can use a graphing calculator. And these are set up perfectly for your graphing calculator. One thing that's nice about Desmos is as opposed to the graphing calculator, you always have to be solved for y. With Desmos, just put it in and it'll figure it out for you. How many solutions does it have? There it is. So no solutions? Okay, so we can tell if it has 0, 1, or 2 pretty easily, right? Okay. So next part we want to be able to do then is we want to be able to solve them using substitution. Now, could we go in and put these into Desmos to find the solutions? Of course we could. Right? But Desmos isn't always available to us, so therefore we have to be able to solve these in different methods. Just like we did when we were solving linear systems of equations. We used graphing, we used substitution, and we used elimination. Okay. Elimination would be not much fun with this, could you? Yeah, I suppose. It would be horrible, but you could. I wouldn't. So we're going to use substitution. So if I have y is equal to 3x squared plus 3x minus 5, that's my quadratic. And I've got 2x minus y equals 3, that's my linear one. If we're going to use substitution, what should I probably do first? If I'm going to use substitution, what should I do? I'll give you a hint. It's in equation number 2. Solve for y. So in equation 2, we're going to solve that for y. So if we solve that for y, I'm going to subtract 2 x's from both sides. So that gives me negative y is equal to negative 2x plus 3. We don't want y to be negative, so we can just go ahead and switch all the signs. So we get y is equal to 2x minus 3. So now I have another equation. Now what? Substitute. Substitute what? Y in for y in my first equation. I know what my y value is equal to. Because I know what my y value is equal to, it's equal to 2x minus 3, I can take the y in equation 1 and substitute it with 2x minus 3. Now 2x minus 3 is going to equal 3x squared plus 3x minus 5. Now I've got one variable, I've just got x. So I'm going to solve this for x. Well, I've got a quadratic, I've got 3x squared. So that means I have to first set it equal to 0. So I'm going to subtract 2x and add 3 to both sides. So that gives me 0 is equal to 3x squared plus x minus 2. Okay, now I've got a quadratic. I've got it set equal to 0. Now I need to solve it. So we've worked on 3 ways to solve. You could factor it. You could complete the square, or you can use the quadratic formula. Okay, completing the square, yuck, not a chance in the world I'm going to complete the square. I noticed that 3 times 2 is 6, and I can get to 1 using 6. So I'm probably going to factor this. If you can't go through that quickly in your head, quadratic formula is always going to work. Okay, so we get negative 6 on the top and 1 on the bottom. So that's positive 3 and negative 2. But remember, I had an a value that was 3, So I have to divide by 3. That reduces to 1. So my first would be 0. If I factored it form, that would be x plus 1. And this would be 3x minus 2. Now I use the zero product property, so we get solutions of negative 1 and 2/3. Here, we talked about this the other day. Our zeros are right in the middle. You just have to remember that it's the opposite of them. Okay, so if you're just trying to find the solutions, you have to remember you can just stop here. You don't need to put it in factored form. Just remember it's the opposites of what's ever here. That's why that works. Because essentially you're finding the zeros. Okay, so now I know my x values. I know my x values are negative 1 and 2/3. I don't know the y values yet. I have to find them. Okay, so don't get to this part and say, I'm done. No, you're not. You're trying to find a point where they intersect. That means you have to have an x value and a y value. This is just our x value. Which color do I plug it into? Red, purple, or blue? Where's the easiest place to plug it in? Red, purple, or blue? Blue. Blue is already solved for y, isn't it? Blue is already solved for y right there. I know my x value is negative 1. So this is going to be in highlighter, evidently. This is going to be y is equal to 2. My x value is negative 1 minus 3. It's negative 2 minus 3. So my y value is negative 5. So one of my points of intersection is negative 1, negative 5. The other one, y is equal to 2, which is the same thing as 2 over 1, times 2/3 minus 3. Multiplying fractions is no problem. Take the top times the top, and the bottom times the bottom. So 2 times 2 is not 2. 2 times 2 is 4. So that gives me 4/3 minus, we have to have a common denominator. Common denominator is going to be 3. So negative minus 9/3. 9/3 is the same thing as 3. 4 minus 9 is negative 5. Denominator stays the same. There are your two solutions to that system of linear and quadratic system using substitution. All things you know how to do. It's just all starting to put it all kind of together to make sure that you're good to go. Questions with that one? All right, let's go. If there's no questions with that one, do that one. Work with the person beside you. Give you about 2 minutes. I'll just do the problem myself here in about a minute and a half. You can just look up, find the solutions to that if there are any. Find the solutions or solution or no. How are you two? Do you? All right, if you peek up, should have got 2, -12. So I get y equals 2x minus 16. Substitute it back into my quadratic one, so I know what y is equal to. Subtract 2x and add 16, that gives me 2x squared minus 8x plus 8. Remember, first rule of factoring is factor out a 2 first. Now if you wanted to use a quadratic formula, that's fine. You just would have got a 0, I think, probably. So that's x minus 2 and x minus 2, so x is 2. Substitute 2 back in there, you get -12. Any questions with that one? All right, so there's solving linear and quadratic systems using substitution. Okay, so you got 2 methods to do these. Graphing on Desmos and substitution. Use the method that they tell you. If they tell you you have to do it by substitution in your directions, you have to do it by substitution. If it doesn't tell you and you want to use Desmos, use Desmos. That's why we did it. All right? Last part of today then is how do you go about solving linear and quadratic systems of inequalities. So now we're not looking at linear and quadratic equations. We're looking at linear and quadratic inequalities. And we are 100% going to use Desmos to do these. Okay, so I'm just going to give you about 30 seconds to copy down those 2 problems. So there's 2 different problems, problem 1, problem 2. And again, we are 100% using Desmos to do this. So just like when we did systems of linear inequalities, we had to do all that shading stuff. And we said the solutions where it was double shaded or triple shaded or all of those things. It's the same thing here. Okay, we have to do the shading. Again, we're going to let Desmos do the shading for us. Okay, your solutions are all going to be the area where it's kind of double shaded. Since we only have 2 inequalities, it's where they're going to be double shaded. So again, the nice thing about Desmos is you can put it in Desmos just like that. And when you put it in Desmos just like this is your first inequality. There's your second inequality. We put them into Desmos. There's what the first one looks like. And notice how it's shaded. Shading is done a little bit differently with inequalities. What you do when you're shading inequalities, what you do is you pick a point that's inside of the figure, and if it's true, then you shade in that area. If it's false, you would shade in the other area where that point wasn't. So y is less than that is there, so there's our first one. There's our second one. Now the area that's been double shaded, which is this area here, you can see where it's double shaded as easily as I can. All of your solutions for that system are within that region. Right? And again, the nice thing about Desmos is you can just type it in just like that. You don't have to solve for y. Don't have to do any of those things. You can just do it. So there's what the first one looks like. The second one, there's your first graph. There's your second graph. The double shaded region is where your solutions are for that system. Happy, happy, joy, 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 happy, happy. You good to go?